In this video, we'll focus on the negative powers of a matrix. From the previous video, we have known that a bar 2, it's mean a multiplied by a. And the same thing, a bar 3, it's mean a multiplied by a. And of course, a bar n means as the matrix product of n copies of A. The same thing here. This one is the same as here, but here we have A power minus 1 multiplied by A power minus 1 multiplied by A power minus 1 and so on. So here we have here power minus 1. So here we have n copies, the same as here, but here we have a power minus 1. And this called in linear algebra a inverse. So it's obvious to know that a inverse, it has to be exist. So this is the most important condition for the negative bar. If you know this, so you can find everything here, so include this one. So A inverse, it has to be exist. And the same rules as the previous video, all of them, you can apply them. So just this extra condition, it has to be A inverse exists. So this one, it has to be exist. And of course, we know that if A inverse exists, it must be a square matrix. So a square matrix is essential property to be A inverse exist. So let's write this one in here. So I will write here the condition of the negative powers. The condition of the negative power, the inverse of the matrix exists. So in our case, A inverse is exist. So it has to be exist. So if it exists, you can find this A inverse A bar minus 2, A bar minus 3. If it's not exist, so it will be undefined. So now let's write also the properties. Properties. If A inverse, this A inverse exists, then I will write here three properties. 1, 2, 3. So let's say here A inverse and the whole thing power minus 1. And we know minus 1 multiplied by minus 1, it will be 1. So A 1, which is A. The second property, A power minus n equal to A minus 1, the whole thing power n, because n multiplied by minus 1, it will be negative n. And the same thing if we write it A power n and the whole thing power minus 1. So this property is very important, and it's very easy for us to find A power negative n by take the inverse of this one. So if we have the final answer for this one, we can take the inverse of this one and we will get this one. So very important property, this one. And the last property is if we have scalar here, let's say t, it's here, I mean any number multiplied by a, and the whole thing power minus n, because here we want it as a negative number. So this answer, it will be t bar minus n and a bar minus n. And we know here if t any scalar, so we know any number bar negative, it will be down in the denominator. So here it will be 1 t bar n, and here it will be the same, where t is any scalar, and of course t not equal to 0. Scalar here, just I will illustrate what's mean of scalar. Scalar, it's mean any number. So that's it here. So these properties are very important to know to find this one. So A inverse, it has to be exist to find or to answer question number 3 and question number 4. And we know from the previous video, we have these properties here. We have written all of these properties, and we know here, for example, property number 1, a bar 0, it's equal to identity. A bar 2, it's mean a multiplied by a bar 3, it's mean a multiplied by a multiplied by a, or you can write it like this. And here the same thing, a bar b multiply a bar q. And we know that if we have here, for example, -4 or -2, you have to add them up. So -4 plus -2, it will be -6. So the same as we did. So you can apply it for any integer, not necessary to be non-negative. But we have to know if we have any negative integer power, we have to know A inverse, it has to be exist at the beginning. Then we can apply this. To illustrate this more, here A multiplied by B, and as we defined A and B, n by n matrices. So here A matrix multiplied by B, it's not necessary here A to B has inverse, but here if we want to raise them to power minus A multiplied by B, so AB, it has to be exist the inverse here. So it's not necessary to has here the inverse of A, because we only interesting inside the bracket. But here, so here it's different than here, because here two matrices multiply together. And of course here it's not necessary to has here A inverse, but because we are interesting inside the bracket to raise them to power minus. So inside the bracket it has to be the inverse, it has to be exist. So here A plus B, it has to be exist. Then we can find A plus B to power minus 2, for example, or 3 or anything. And the same thing here. So after this, so we can find A B power minus 2. So, and of course, whatever here A, B, power minus 3. So we can find it. So we can find here if A, B exists, the inverse here, we can find A, B, power minus 3. So that's it here. So we know now that to raise any matrices to power minus, so the inside the bracket, or if it's only one matrix, it has the inverse has to be exist. That's it here. So let's go down. Now let's solve number 3 and number 4. So we have to find the inverse. So let's write it here. 3 we have to find A inverse, so we have to write it like this: A here, like augmented matrix. This called it augmented matrix, and of course here the identity is 2 here because it's 2 by 2 matrix. This equal, we have to go up and to know what's A, 1 1 0 1. So 1 1 0 1, and here we have to put the augmented, and here this identity 1 0 0 1. And of course you can decide it if A inverse is exist by take the determinant, and if this determinant not equal to 0, it's mean A inverse is exist. But in this video we'll focus to do this. And of course we have to do this as RREF, which is reduced row echelon form. And if we do reduce row echelon form for this here, this matrix here, then if we get identity matrix, then A inverse is exist. So here, so let's do RREF. So this one we have to make it 0 because you are like this. You are like from here, then you go down, you find 1, then you go right, then if you find any number, so you have to make it 0. So this one we have to make it 0. So row 1 minus row 2, because 1 minus 1, it will be the 0 in R1. So 1 minus 0, which is 1, 1 minus 1, which is 0, 1 minus 0, which is 1, 0 minus 1, which is negative 1. Here the same thing, because we don't need to change this row, so 0 1 0 1. Since here we get here identity matrix, which is 2 by 2 matrix, then here this is A inverse. So this is identity matrix here, and this is A inverse. Therefore A inverse is exist. Therefore A inverse equal to this one: 1 negative 1 0 1. So let's back to the question. So find A bar negative 1, A bar negative 2, A bar negative 3, and guess a formula for A bar n, where n is any negative integer. So we will find A bar minus 2, then A bar minus 3, then we will guess the formula. So let's back here. So A bar minus 2 equal to A bar minus 1 multiplied by A bar minus 1. So I will multiply this 2 times. So let's copy it from here. Now let's multiply them together. So this row with this column, 1 multiplied by 1, which is 1, plus negative 1 multiplied by 0, which is 0. Now this row with this column, 1 multiplied by negative 1, which is negative 1, plus negative 1 multiplied by 1, which is negative 1. Now this row with this column, 0 multiplied by 1, which is 0, plus 1 multiplied by 0, which is 0. Now this row with this column, 0 multiplied by -1, which is 0, plus 1 multiplied by 1, which is 1. And this answer it will be here 1, here -2, 0, 1. Now let's find a power -3. So I will write a power -1 multiplied by a power -2. Of course, you can find it as a power -2 multiplied by a power -1. It will be the same thing. So here I will write this here, and I will copy this one here. Okay. Now we will multiply this row by this column, and we will get the first element. So 1 multiplied by 1, which is 1. -1 multiplied by 0, which is 0. Now this row with this column, 1 multiplied by -2, which is -2. -1 multiplied by 1, which is -1. Now this row with this column, 0 multiplied by 1, which is 0. 1 multiplied by 0, which is 0. Now this row with this column, 0 multiplied by -2, which is 0. 1 multiplied by 1, which is 1, so plus 1. So here it will be 1, -3, 0, 1. We can see here there is a pattern. These elements are the same, except this element, every time it's increasing by -1. So we can conclude that a power n equal to 1, 0, 1. These are the same every time. 1, 0 here and here 1, except this one. So here we put n, where n is negative integer. So you can substitute any number here. For example, -100. Here we have to write here -100. So here we have to find a power -2025. So let's write it here. So for a power -2025, and this is equal to 1 -2025, and here it has to be 0 and this one has to be 1. So that's it. We have solved this problem. Now let's conclude what is the formula for a. This extra, like I will write it as extra from 1 and 3, as we did here. We see that number 1 here we found this a power n for positive integer, it will be this, and the same as we have done now. So here for negative integer we have the same formula. It's not always it will be the same, but here in our case we have the same formula for positive and negative integer. And of course here a power 0, it will also satisfy our formula. So if you substitute here by 0, here you have to substitute, of course, here 0, it will be identity matrix. So this formula, it satisfies for positive integer, 0, and negative integer. So let's conclude it here. It's not the answer for our question, but I like to write it here. So if A equal, so here we have A equal, this one's here 1 1 0 1. We have A bar n equal 1 n, here the same as this formula, 0 1, where n is any integer. It's not necessary to be positive or negative or 0 as well. So any integer. So that's it. Of course, there is another way to find integer bars of a matrix. For instance, by diagonalize a matrix, then easy we can find the bars of the matrix. I will talk about this method, which is diagonalize a matrix, at some time in the future. Thank you to watch this video.